How do I get it to switch back to? Oh, there we go. It's a bit off to the side. There we go. Thanks. So I see a lot of people with nice little Macs here. I brought the biggest laptop I could find, this one, so I could hide behind it if someone throws something at me. And incidentally, it also has probably the biggest power supply that you can find, which serves as a weapon. Just a quick few words about me. I work at Bekk. I'm also part of the OWASP chapter here in Oslo, so if you're interested in security, please come by. This is sort of a drawing of a simple web application. We have some services that serve some JSON. We have a web layer that serves some HTML, maybe some CSS, stuff like that. And we have some client logic written in JavaScript. We have the actual web layer, which displays the HTML. Today we'll mainly focus on the upper bits here, not the lower bits down here, because this is a front-end conference. We'll talk a little bit about what's going on here as well, but not that much. So let's go ahead. But first, this is 472 bytes of something. All right. I thought that I'd base this talk on the OWASP Top 10 because the OWASP Top 10 has sort of become a standard for what you need to protect an application against. And it's based on risk, and it's based on prevalence. So any common bugs are in this list. And we'll start at the bottom because the top ones are the most interesting. So we'll just briefly skip through the boring ones and then get to the meat of the matter. The first thing is unvalidated redirects and forwards, which basically means this is not what you're looking for. Go on to the next one. Typically, in the old world, that would look something like this. We would allow our browser somehow to just redirect to an arbitrary URL. Typically, that would be on a login form, where after you'd log in, it would redirect you. And the functionality was supposed to redirect you somewhere else on the page where you wanted to go before you were asked to log in. But some pages allow you to just go anywhere, and then you could do this as a sort of phishing site. But this happens in the web world as well. This was from Twitter back in 2010 in September, where the intention was to be able to go from this URL here and down to this URL here. But the problem was they weren't really validating what was coming in. So you could basically do something like this. And you'll get the slides later. There's a link down here to a blog post, which you should read, because it explains how they tried to fix this and failed multiple times. And the guy who's written the blog post was helping them out. So what you basically need to do is sanitize or whitelist your redirect locations and do it properly. As simple as that. The next thing is insufficient transport layer protection, which basically means just use HTTPS if there's private data and use it always. And lock down your SSL config because, I mean, SSL can be anything. There's actually a cipher in SSL that's named null with null, which means there's no encryption. So it's plain text over HTTPS. It's most of the time not enabled, but still it can be. So get rid of those. But if your login page is delivered over HTTP, it may not matter if the form submits to HTTPS, because there's many ways to trick this. But there's a tool called SSL script that you can just use on a wireless network, and it will replace any links that are in or any form actions that are flying across the ether and down to your laptop with HTTP. So when you're submitting, you're actually submitting to HTTP instead of HTTPS, which you thought you were. So don't have login pages on HTTP. The next thing is failure to restrict URL access and insecure direct object reference. And these are, I've combined 2 points here because they're very related many times. I'll define 2 things first. There's vertical access control, which means are you an admin or are you a normal user or are you anonymous? And then there's horizontal access control, which means data access. And to show you this stuff, I'll show you a small little demo app that I made, which looks terrible. It's written in Rails and Backbone. It's my first Backbone app, so the JavaScript is, yeah, the quality is not for copying. And it's very simple. We have a list of talks. This is a conference. We have like, you could go in and look at a talk, which is like funnybone.vbs, support of Backbone.js to VB scripts. Very useful, probably. No. And we, because I'm the author of this one, I can go in and edit it and save the changes. But if I go on something someone else made, there's no edit button. Also, if I log out and then log in as an admin, there's a new menu item here, users, where I can edit the users, and I also have the access to approve a talk. So let me log in back as myself. Let's go with the vertical access control first. Let's say I want to be an admin, and there's, let's say this application is not all that great when it comes to security. So fortunately for me, I know that it loads the user somehow. And because I can just do an F5 and I'll see that on the network tab. Let me bring that up for you. If I go to XHR, I'll see it loads a profile, and within that profile, there's some data about me, and there's a field called role, which is now empty. And if I do something like this, and then go back and start to look at talks, I'm now able to approve them, right? This is just simple changing JavaScript, changing the data on the client side. I mean, it's not a big deal really, because I mean, you could do this with GreaseMonkey, you could do this with anything. But it's really important that we think about these things when we develop applications, that what happens on the client side doesn't really matter when it comes to the security of the application. We need to actually secure the services that are behind and have them do this the correct way. I could do the same thing with the horizontal access control. That I couldn't edit a post that was there. Well, I can go in and change the owner of that post to be me in the browser, and then I can edit it. So we need to have a way to actually secure these things, and it needs to be done on the server side. The next thing is insecure cryptographic storage. And we don't really do that much crypto on the client side, but we need to think about what it actually is saying. It doesn't say that we need to have crypto, it says that it's insecure somehow. And that might just mean that we're storing things on the client side that shouldn't be there once the user logs out. What about local storage? Is it stored? Well, it's stored until it's deleted. Session storage is deleted when you exit or restart the browser. But is that what you'd think it would do? Like if you log out, wouldn't you expect it to delete all your private data from that machine if you're in a library? And of course, there's caching, which was brilliantly presented in the previous presentation. What about if we cache private stuff on the computer or on the mobile phone? Is that a big problem? It might be. And these are some data from a site called missingx.com, which is collecting lost items on airplanes. So we can see in the few previous days, there were an amount of iPhones forgotten on planes and a lot of iPads. And these are just within a few days. And these devices are stolen all the time. So we need to make sure that the data that we put on them, we need to have we need to assess whether or not it's okay to have it there. So it's always okay to cache things like CSS, JavaScript, etc., but it might not be okay to cache private data. It depends on the site, but we need to think about it. Server-side crypto, TMNT means too much, no time. There is a cryptographic storage cheat sheet, which you can look at later. And do so if you're ever in need of crypto. The next thing is security misconfiguration. There are very, very many things that you can do wrong here. I'll just mention a few because in the new things that we get from HTML5, we get a lot of new functionality that we didn't have earlier. And this is one of the things that I'm afraid we'll see a lot of. What these headers say is that any web page on the web can connect to me and can include its cookies, and I'll just give them data back in the browser. So I might be logged into Gmail, and if Gmail was sending these headers, then any other page on the web could go to Gmail and get my Gmail address, my Gmail stuff if I was going to their site. And to put this in context, there is something called cross-domain XML, which is basically the same thing for Flash. And there's insecure configuration of this has been out for a very, very long time. This is stats from the 18th of May from the top 100 Alexa domains from Sweden, Norway, and Denmark. There are 30 cross-domain XMLs for Norway, and a lot of them were insecure. That might not be a problem if that site is only serving public data, but again, it's something that we need to think about and not just add. So what about these two? Is that a problem yet? Well, let's ask Shodan. Shodan is a search engine that allows you to search computers. It's like a Google for machines or Google for servers on the internet. And it basically just goes to any computer it can find, and it asks on any port it can find. So it's sort of a port scan, but then put into a search engine. And we'll see there are 347 of these already that have these headers set in the US, in Italy, in Germany, France, and Spain. And so this tool is really powerful to see whether or not these things are used or not. And yeah, some more stuff. This time a bit shorter, 136 bytes. The next thing we'll talk about is cross-domain request forgery. Does anyone not know what cross-domain request forgery is? Some of you? Basically, a website that has a form or a URL that accepts posts, it has to know that that post originated from itself, or else any other web page on the web can post to that URL. That's the short story, and there are some really good pages on OWASP and Wikipedia that you can look at. I'll show you one example. There's a guy called Igor Homakov who posted a blog with CSRF vulnerabilities just recently, and he had found CSRF vulnerabilities in GitHub, SlideShare, Vimeo, Bitbucket, and Heroku, and I'll show you the Heroku one. It looked like if you add an image tag to any site and the user is logged in to Heroku, this would actually change the URL of the app on Heroku. So it would rename the site from XXX, which was the first part here, to YYY, just with a simple image tag. So that could be put anywhere on the web, and you could trick the user into visiting that page by posting him a shortened link on Twitter or anything. So yes, this is a problem. You could also do file uploads. You could just build XHR request, which contains file data, and build a multi-part form inside the request and send it off. And that way you could upload a file. You could upload a malicious PDF, or it could be anything. So in most frameworks these days, they support what's called anti-forgery tokens. This is a simple way of just adding them to all XHR requests that are of type post. And I've used this many times. It works perfectly. You just have to have a way to generate this CSRF token on the server side, put it in the session, and you compare the two once they get back to the server. And then you know that it came from the correct place. Broken authentication and session management. This is a picture from Anders Nuos. They have a new great door with RFID chips and stuff like that, but you could just skip over here if you want to get in. I hope they fix that later. I hope this was a part of just building the thing. It's really important that we, when we move to building JavaScript-based apps, which rely heavily on client-side logic, that we still have the same ways to log a user out that we do on the old kinds of web applications. So we can't just delete the cookie on the client and say, yeah, now you're logged out and you can't do anything. We have to terminate the session on the server side. And we have to think about what's left behind in web storage. Is that okay for us? And how does the client know who's logged in? Can you manipulate that on the client side and be someone else? And will the server accept it? And of course, we shouldn't lose track of our current session policies, like session should time out. We could just return a 401 when the session times out and handle it on the client, so redirect to the login page and then ask the user to log back in if that's the problem. The most important things, in my opinion, is to look at cross-site scripting and the last one, which is injection, because those are some of the more difficult tasks to solve. So there are many types of cross-site scripting. The first one is called reflected, which basically means the attacker creates a URL which contains an attack, sends it to the client via maybe a shortened link on Twitter. The user clicks it, sends it to the server, gets something back, and it runs some JavaScript that was included in the original URL. Then there's stored cross-site scripting, which means the attacker sends something bad to the server, which is stored in the database somehow. And then when the client gets it back, it runs JavaScript in the browser and does something bad. But one of the new things that we see more and more in JavaScript-based applications is DOM-based cross-site scripting, which means you can send the user a URL, and it doesn't send it back to the server. It just happens directly in the client. An example of this is this one. So we see here, here's the hash sign, and all of this is a path or in the hash, and this would actually run the script. And I can show you this on this dumb app that I created, because when you're browsing the talks, I'm not sure if you can see this, but in the URL here, you can see the name of the talk. It's pretty hard to read. It's the same name here, just lowercase with dashes instead of spaces. So if I then go ahead here and do script, it will run that script, because it's trying to say it couldn't find a talk with the ID that I put in here. So that's a simple DOM-based cross-site scripting attack. Another one could be on this conference page. I have the ability to register a new talk that I want to submit, and I could then just maybe I'll do it in another way. I could do something like this, and I'll save that as a draft for later. So now when I go back in, the JavaScript fires, and it will do that every time I try to enter this page. And this is a persistent client-side cross-site scripting attack. The attack itself is stored in the local storage on the client. And this is really hard for the server side to detect. There's really no way you can know that this attack has happened. There are many ways to get cross-site scripting in this application. You could just enter a script tag here and submit it, and it will run later as well. It's a really crappy app, intentionally. And of course, there are some unsafe JavaScript functions that we need to be aware of. And the most prominent ones are these. The ones that build JavaScript code from strings. It's really hard to get it right if you start putting user data inside eval or set timeout or set interval or new function. And there have been many, many attacks on this, which have led to cross-site scripting. When you're using jQuery, you have to remember that if you're using any of these functions, whatever you send in as an argument here is treated as HTML, not as text. So if you're sending in the username, if you're sending in the first name of the user, if you're sending in an address, it's treated as HTML. And if there's a script tag in there, it will run. The safer functions are, of course, text, and then the one that you use to set attributes. But of course, it's not safe if you use it with an event handler, but you shouldn't do that anyway if you're doing a JavaScript-based app. There's a tool on GitHub called the jQuery encoder, which you can use to basically escape things properly. So you can escape things for the different contexts that appear on a page. And this is really important because a lot of people think that escaping, yeah, you just escape for HTML and then you're done. But it's not that easy. And when you use templates like underscore or whatever, mustache, you have to know when they escape and when they don't. So what kinds of coding and output possibility do they have? Does it escape the input? What kinds of escaping does it do? Is it escaping context-based, like I talked about earlier? If we look at underscore, it has these three. The first one runs code. The second one just outputs directly. So if there's a script tag in there, there will be a script tag in the page. And the last one does HTML escaping. And this is the way the escaping function works. It replaces and with the ampersand and etc. All of these, which is all well and good as long as you're not outputting inside JavaScript event handlers, which you shouldn't. But anyway, if we look at the first one here, there's a confirm inside an onClick handler, and we're outputting data directly inside here, and it is HTML escaped. But when this thing happens, this code here will actually run and the alert will pop up because this is escaping for HTML. It's not escaping for JavaScript. So the escaping is first removed when the page is parsed, and then it will run whatever JavaScript comes out in the end. Same thing goes here. If you're outputting things in attributes and you don't put quotes on each side, which you always should, you could just add a space and then a new attribute and then game over once again. And you should not be outputting data inside style attributes or tags or script. And there's a really good resource here, the OWASP XSS prevention cheat sheet that you could look at. Meanwhile, elsewhere in Norway, I found this about a year ago. This is the entire HTML file. I reported it at the same time that I found it, and it's still not fixed. What it does is it takes the part of the URL that comes after the question mark, it splits it on the ampersand, it takes each of these, splits them on the first equal sign, and builds an array called URL. And then it writes a script tag where it picks the URL parameter named source and puts it in as the source of the script tag. So you could include any script file on the world using this page. So it's just horrible. I don't know why they didn't bother fixing it. It could be used for phishing. It could be used for anything. So don't do this. There's an upcoming standard called the Content Security Policy. And it fits well with the single-page JavaScript web apps. What it does is it allows the server to instruct the browser what it's allowed to do. So here's an example. It says that you can load images, you can load style sheets from anywhere, or no, from myself, but you can load scripts from myself and Google APIs.com. So if I try on this page to load an image from Google, it will fail because I say I'm only allowed to load images from myself. And you can use star if you need to be able to say load images from everywhere because you don't really care where they're loaded from. What it also does is it disables these unsafe functions. You can re-enable them if you want to, but that's probably not a good idea. It also disables inline CSS and JavaScript, which you might say improves the quality of the website, because then you can't use those anymore. And that will stop things like injecting script tags and things like that, which is good. But it can be a bit of a hassle to add this to an existing website. But there is a way to run it in a sort of reporting mode. We'll report any violation back to you, so you can create a good policy and then really go live with it. It's currently supported by Chrome and Firefox, and is rumored to be in IE 10. And you can specify anything. You can say images, you can say videos, you can say objects, flash, and things like that. So you can restrict really down to in a really detailed way what's allowed to be loaded into the page. The last thing I'll talk about is injection. And here are a couple of client-side injections that I've seen. One of them is URL injection. We have a search form, and what I enter as a search term is frog slash dot dot slash dot dot etc. logout, and the URL that's been sent back from this search from XHR becomes this, which means it goes to the logout page and you're logged out, which doesn't really matter all that much, but you could do anything with this. Similarly, you could, if you don't escape the data properly before you put it into the URL, you could add new parameters to the URLs and things like that. That's happened on AOL.com, for instance. JSON injection, if you're not properly building your JSON, if you're doing string concatenation, again, which you shouldn't, we could do something like this, add a new value, because we just go out of this one using a quote and then open up a new one and add something new. So do JSON properly. On the server side, a lot more can happen. SQL injection, of course, but we're not talking about the below layers today. NoSQL injection, same thing. But what about JSON APIs and JS-based backends? What can happen there? I'm going to show you a quick demo in Node.js. This is not a bug in Node.js. This is unsafe use of JavaScript in a Node.js application. It could look something like this. Instead of parsing, what it does, it accepts some data, and then it gets the JSON string to be become an object. It does eval instead of doing JSON parse, and that's a horrible thing. And I'll show you why. So here is a simple website for getting stock quotes. Let me bump that up a bit so I can enter a ticker, Facebook, and I'll get some data back. Oh, I didn't really type that correctly, like that, and I'll get a quote back for the stock. This is a really simple application, so it doesn't really get data from anywhere of importance, but this is just the server side. I can see what I get in, and that's just to help us see what's going on here. So I'm going to use a tool called Postman, which is a Chrome extension, which is great for fiddling with JSON APIs. So I can, what happens if I send in, this is quite hard to read, but after the symbol here, I insert a function in the JSON, and it says while one. So I send that in, and it says they're fetching data, and it's not coming back. So what's going on the server right now? Well, we see Node is running here at 100% CPU, trying to evaluate that statement, and it's not getting back. So let's, this is the way, maybe it's a bit easier to read here. You see the function here, that's a function that's immediately evaluated after it's declared. It just says, while one. So let me stop that and open it again. And then go back and open Postman again. And we could also do a file read. This time I'm sending in a function that's just doing require fs and then tries to read the etc password file on the laptop. And as we see in the result down here, it actually managed to do so. So never use eval if you're in a Node application. It's bound to go wrong at some point, at least if you're using client-side data. You could do anything with this. Like you could do a DOS attack, like I was doing with the while thing, where it never responds back. You can attack other servers, read local files, grab the entire database. So this is worse than SQL injection. It's really easy. upload arbitrary files and execute them on the server. I've seen examples of this. On the previous slide, there is a link down here to a video on YouTube where you can see this happen. Once again, this is not a Node.js bug. It's unsafe use of JavaScript on the server side. The next, just one thing. JSHint says eval is evil, and I tend to agree. So use with caution. It's of course okay to use something where you are in full control of all the data, like in the underscore templates. You have a static template. You're compiling it. That's okay, but don't use it with client-side data. The next one is mass assignment or overposting. Once again, this Igor guy, he did some funny stuff. This is really hard to read on this projector, but it says here, Homakov opened this issue in 1001 years, so in the future. And it says, I'm Bender from the future. Hey, where is the suicide booth? And the problem here is, are we still in control of our model when we're moving the model over to the client side? And of course we're not, because the client can do anything. So what he did was he altered the timestamps for when the object was created. And he also added his own SSH key to the Rails project and made a commit to master. And he did this to prove a point. He was not intentionally evil. He was just saying to them, this is a bad thing. I'll show you a demo of that as well. So I have, let's say I have this, okay, yeah, I'll just refresh it so I'm not an admin anymore. I have this talk that I would really like to have approved. So the first thing I can do is look at what's sent back to the server. And when I save a change here, it does a put. And I see that what it sends, scroll down a bit. It's a bit hard to read here, but it says here approved false. But this is already there, but I could easily just manipulate that by adding stuff or just manipulating the JavaScript. But what I would like to do is, because I was submitting this talk a bit late, I would like to backdate it. But there's, it's not sending any dates here. But when I look at the response, I see that there is a date. There is updated at, there is created at, etc. So that's something we could easily mess around with. First, we could get our talk approved just by, once again, using Postman. So now the response says approved true. I just changed the JSON that was sent back. And then I could add, I could just grab what it sends here. Even though it's not normally sent back and it doesn't exist in the form, if the server side accepts it, it will happen. So, and I'll backdate it to April. And now if I go back in, it says April here. So that's exactly the same attack that Igor did. And you could do this with anything. You could say you have a form where you could update your user account and add a new name or something like that. You could add a new field that says admin or role and admin, and maybe you'd become an admin. That's happened before. Finally, some more gibberish. This time 106 bytes. What is this stuff? Does anybody know? Well, it is JavaScript. And it's a non-alphanumeric way of saying alert 1. So there were these guys, they were fiddling around trying to find the shortest way that they could do alert 1 without having alphanumerics for injection purposes. And there are some shorter ones, but they rely on Norwegian characters, and they say that those are not alphanumeric, so I don't quite agree with them. So I took this one, which was the shortest one that didn't have any ace or with the circle above and things like that. if we have a web app that looks more like this, where we have a mobile UI also, which is not a web app, which is actually a mobile application, we might have some services here that not only give us back JSON, but they might also support sending back and forth XML. And there are a couple of things that you can do here. What I'm doing here is I'm using an entity called M, and the entity M is defined here as LLLLLL, and the entity L is defined as KKKKK, etc., all the way up to the top where it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Does anyone know how big this XML will get when it's parsed, if it's parsed in an unsafe way? That's probably more memory than your server has. So you need to have safe XML parsing on the server side. Same thing, just a different way. You could just indent many times, and you might use up the memory on your server because it's building up a DOM tree and it grows out of bounds. A last one, XML also allows you to grab files from a file system, from a URL, etc. So here I'm doing the same thing as I did in this node attack. I'm grabbing the etc password. I'm including that as an entity here, which used to work in Jersey, the JSON API that you normally use on Java-based apps. It used to work in Jersey about a year ago. If you want to read a really good book about securing web apps, I highly recommend this one. I recommend it regardless if you're interested in security or not, because it covers the basics from how web browsers were started, the origins of HTTP 0.9, which doesn't have any response headers, and how URLs are interpreted in the browser and things like that. And some final advice: build robust JSON services with clearly defined transformations. So my app clearly didn't have that. You could just send in anything and it didn't check it. So don't just pass a model back and forth and assume that no one cares about changing it. Someone will. Remember to test the evil test cases, what should not be possible. So do that in an automated way as well. Seek frameworks with secure defaults. I like frameworks that have HTML escaping by default because that's a lot more safe than not having it. So I like, if I'm using underscore, I tend to flip the two where it says percentage equals, which is not HTML escaped, and percentage dash, which is HTML escaped. I like to flip them because people are used to using percentage equals. So that's it's better to always be on the safe side. As a developer, always default to the secure function. It's better to err on that side. So use .txt, .text in jQuery instead of always using .html. You better be sure if you're using HTML that it's actually just text that's coming in, or you better be in control over the HTML somehow. And you're testing your JavaScript, right? So why not also test your templates? Put some evil data in your templates and see whether it pops, see whether you can manipulate the HTML somehow, and make sure that that doesn't work anymore. And remember, a Lannister always pays his technical debts. And here are some suggestions of people to follow. Hard to read, you can see it later. Really good security guys. You should follow them and take their advice. And my contact details down here. Any questions? Yes. You need to, the question was, is how do you escape for cross-site scripting? Is it enough to escape the less than sign, etc.? So the answer is no, it's not enough. You have to escape all sorts of characters, like you saw in the underscore template, which does a decent job. If I can find it here. It escapes all of these characters, and that works in most cases, except the ones that I had on the next slide. This is pretty much covers much of what you'll encounter. as long as you're not using quoteless attributes and things like that, and as long as you're not building strings from JavaScript and putting in JavaScript event handlers in HTML, etc. So this does a decent job, but it's not good enough for putting data inside style sheets, where you have weird things like expression in IE, which runs JavaScript inside style sheets. And one of the guys they had Twitter accounts for on the last slide, he found a way where he could do key logging using only CSS. I think he built a font, a web font in SVG, where every character had a different height. So whenever you're typing something in a text field, that would do something weird with the browser. So the browser would grow, and he then used the background URL and things like that to see how far down are you on the page, and he submitted things back to the server. So only using CSS. There are a couple of good resources for cross-site scripting. There's one called the OWASP XSS prevention cheat sheet. There's the OWASP DOM XSS-based prevention cheat sheet, and there's one now, which is probably the best one, which is called the OWASP abridged XSS prevention cheat sheet, which is more aimed at developers and is a lot better in my opinion.
Yes. You probably turned off most of the safeguards in Rails, right? Because Rails is more secure by default, I think.
Yeah. You heard the question. I did turn off some safeguards in Rails. I did turn off the anti-forgery token, but any of the attacks I use now could easily have been done with that one on. I did probably some more things. I can't really remember what, but a lot of the frameworks that we use today are not really all that secure by default. One of the recent things that we see from Rails is that Rails by default thinks that all regular expression, or that's actually a Ruby thing. A Ruby thinks that all regular expressions are multi-line. So if you use an input validation rule where you say the start of string and end of string as a $, that will match just a part of the string. If there's a line that matches that, it will match that. So if you have a function for figuring out whether a URL is starting with HTTP or HTTPS, you could add JavaScript colon and something evil, and then /n for new line, and then HTTPS and something nice and cozy. And the Rails input validation will just say, yeah, I found it, good. But that's not the way to do input validation in Rails. And most people don't know because it's different from all other frameworks. So I don't mean to bash on Rails because I kind of like Rails, but it does some things in weird ways that you don't expect.
I think we're out of time. Give the man some applause, yeah?